faithfully delivering value, interpreting great books from around the world. Hello, this is Sally's Book Talk. The book we're going to interpret for you today is The Girls Who Launched Rockets. In the previous episode, we covered the girls' story. We talked about how the Jet Propulsion Laboratory, or JPL, in the 1940s and 50s went from being an accident-prone suicide squad to step-by-step launching America's first artificial satellite into space. With the successful signing of the National Aeronautics and Space Act, the U.S. space program got on track, and JPL was incorporated into the newly formed NASA, becoming a cornerstone of American space exploration. The female computers at JPL made outstanding contributions in these missions. From the 1960s onwards, JPL, on one hand, took on key projects in the U.S. lunar landing program, and on the other hand, launched spacecraft like Mariner and Voyager, heading towards Venus, Mars, and even beyond the solar system. What role did JPL play in the Apollo moon landing program? What are the stories behind Voyager's journey through the solar system? Facing technological and social progress, what changes did the female employees at JPL experience? How did they respond? Next, we'll divide it into lunar missions and planetary exploration missions. These two parts will be interpreted for you respectively. First, let's talk about JPL's lunar missions in the 1960s. At the start of the U.S.-Soviet moon race, the Soviets were still in the lead. On January 2, 1959, the Soviet Union launched Luna 1. This spacecraft was intended to land on the moon, but it ended up missing the moon and slipping into solar orbit. However, this still allowed the Soviets to proudly claim that Luna 1 had become a planet orbiting the sun. 8 months later, Luna 2 crash-landed on the moon's surface, becoming the first human-made object to land on another celestial body. On April 12, 1961, Soviet cosmonaut Yuri Gagarin boarded Vostok 1 and entered Earth's orbit, becoming the first human in space. In the space race, the U.S. was frequently behind the Soviet Union, which made the U.S. double its efforts, wanting to be the first to put a man on the moon. Where gravity's weak, there's no atmosphere, and a footprint might last 1,000,000 years. Whoever imprints their footprint first signifies the end of the space race. NASA's different divisions had various missions. JPL focused on unmanned missions. It launched programs like Pioneer, Ranger, and Surveyor, sending reconnaissance satellites and unmanned spacecraft to the moon to explore the lunar surface and find suitable landing sites for the Apollo moon landing program. However, the plan didn't start off smoothly. The Pioneer satellite didn't succeed until the fourth one, but it still missed the moon and became the solar system's second artificial planet. Like, OG. The Ranger program that began in 1961 also faced continuous setbacks, failing 5 times in a row. It wasn't until January 1964 that Ranger 6 launched and reached its intended impact point on February 2nd, near the Sea of Serenity on the moon. Embarrassingly, Ranger 6's cameras failed to start because the rocket ignition short-circuited the circuits. The ground receiving center got no photos from the moon, and the mission failed again. It wasn't until July 1964 that Ranger 7 finally launched successfully and sent back thousands of photos to Earth on July 31st. This was humanity's first time seeing close-up photos of the lunar surface, a vast, dark plain dotted with craters, a desolate scene. The next Surveyor program aimed to build a spacecraft capable of soft landing on the moon. The Surveyor looked like a white, long-legged tripod with 2 solar panels on top.
It featured a brand new design, with steerable rocket boosters at the rear above the tripod, working with radar and autopilot systems.
Engineers could control the spacecraft's deceleration from Earth to achieve a soft landing. Previous spacecraft achieved impact landings, where landers were damaged on impact. But to send humans to the moon, safe soft landings were essential. Moreover, Surveyor 3, which landed on the moon in 1967, was equipped with a scoop that could bring lunar dust in front of the camera lens. This was humanity's first time observing the moon so closely, and it also found an ideal landing site for the Apollo program.
On July 20th, 1969, the girls watched with admiration on TV as Neil Armstrong made history by becoming the first person to walk on the moon.
And at this time, they began a splendid transformation, evolving from computers to JPL's first programmers. As early as the early 1950s, JPL introduced an IBM 701, a behemoth that occupied about as much space as most computers' homes. Inside the IBM 701 were tens of thousands of diodes that amplified electronic signals and transmitted externally input binary data. Besides, there were 4 magnetic tapes as storage. To use this behemoth, you had to learn a very obscure digital code. Even simple operations like square roots required writing extensive programs. Although this machine claimed to perform 16,000 operations per second, it frequently crashed. Just one burned-out diode could completely paralyze the entire system. We ride I if it is easy for nothing. Engineers and computers didn't trust it. But by the 1960s, computers became more advanced. They shrunk in size, gained speed, and improved stability. The girls worried they'd lose their jobs, like telephone operators did. By then, Nacy, who built the computing department, had retired, and her deputy Barba was fired for marrying and getting pregnant. After merging into NASA, the computing department was renamed Mission Design Department. The new supervisor was Helen, mentioned in our last episode. This Chinese woman excelled in the U.S. satellite program and was among the most trusted computers by engineers. An engineer alarmingly told Helen, "Your jobs are about to disappear."
All Helen could do was work harder than ever, leading the girls to learn programming.
While other NASA departments laid off female staff en masse, JPL's female computers quietly became NASA's first programmers. One early language they used was Fortran, ideal for translating math formulas into code and compatible with nearly all computer models. The girls, after coding, they'd convert programs to numbers on a key punch machine, press A to start, feed a card, and it'd punch a hole over 7. One wrong keystroke ruined the entire card, requiring re-entry. Complex calculations needed whole boxes of cards. Then cards went into a compiler, converting Fortran to binary machine language. The compiler spat out a second card set computers could read. Engineers rarely touched this work. And so while women at other NASA centers faced mass layoffs, JPL's female computers secured their roles through programming. Their new skills would help unveil the mysteries of Venus and Mercury. Next, we'll move into part 2 of the next episode, JPL's planetary exploration missions. As early as 1958, the year JPL joined NASA, they proposed a series of deep space exploration plans, with the first phase targeting Venus and Jupiter using Mariner probes. In the 1950s, these planets held far more fascination than the Moon. As far back as 300 years ago, people had uncovered many lunar secrets through telescopes. But little was known about other solar system planets, especially the outer planets, Jupiter and Saturn. Planets beyond the asteroid belt were too cold, with extreme atmospheres, while Mercury was too close to the Sun. Only Venus and Mars seemed promising. These Goldilocks planets appeared just right, potentially hosting alien life. As one engineer said, "Since we can explore Venus and Mars, why waste time on that lifeless rock?" The Mariner project planned 10 launches to explore Venus and Mars. Computers designed a Venus trajectory with a Mars flyby to probe Venus's atmosphere. But like all unknown explorations, Mariner missions faced constant setbacks. On July 22, 1962, Mariner 1 malfunctioned immediately after launch, losing contact with mission control. To avoid endangering civilians, the range officer triggered self-destructive after 1 minute. But the computers had no time to mourn. Venus's observation window was short and crucial. They had to launch Mariner 2 during summer 1962, when Venus and Earth aligned. Wait, 19 months! The girls worked day and night checking trajectories and programs. On August 27th, Mariner 2 launched, but its booster short-circuited, spinning uncontrollably once per second as everyone watched helplessly.
Would it face destruction too?
Fortunately, the rocket suddenly recovered and carried the spacecraft into space. On Halloween 1962, about 2 months after launch, Mariner 2 lost a solar panel. In mid-November, the spacecraft overheated again, yet it kept stumbling toward Venus, while the female computers below sometimes gazed at the night sky. What's Venus really like? Could it be covered in tropical jungles, with alien dinosaurs running through steamy vapors? The mystery would soon be revealed. On December 14th, 1962, about 3.5 months after launch, Mariner 2 reached its closest approach to Venus. Right then, the spacecraft's control system failed, forcing JPL's team to manually send commands to initiate the Venus flyby sequence. The spacecraft began its comprehensive survey of Venus. Torrents of Venus data flooded from the teletype. Mariner 2 pierced through Venus's thick clouds. No rainforests, no alien dinosaurs. Venus had extreme heat and pressure, likely with a metallic core partially molten. But Venus's slow rotation, 1 day equals 243 Earth days, prevented magnetic field generation, leaving it without protective atmosphere and inhospitable to life. This Venus mission finally let America defeat the Soviets, scoring the first victory in the space race. On January 3rd, 1963, Mariner 2 sent its final signal, becoming space junk orbiting the Sun. Soon after, Mariner 3 would also fly past Mars. Mars was 4 times farther than Venus, requiring a 7.5-month journey.
Mars's launch window was shorter, just 27 days. Miss it, wait 2 years. Step 1, enter Earth orbit, then transfer to solar orbit toward Mars.
Computers had to calculate exact altitude and azimuth to prevent crashing into Mars. This was because all spacecraft equipment required high-temperature sterilization before space entry. Otherwise, if we found life elsewhere, how could we confirm
Whether it was Martian life or Earth contamination?
But Mars journeys were too long. Sterilization risked damaging equipment. So Mariner went unsterilized, making collision avoidance critical. Another key asset was the Deep Space Network. This network had 3 giant dish antennas in Australia, South Africa, and the US, maintaining two-way communication between spacecraft and JPL's control hub. With the Deep Space Network, spacecraft millions of kilometers away could transmit photos to Earth using binary signals. On November 5th, 1964, just an hour after launch, Mariner 3 failed when its protective shroud wouldn't separate, preventing solar panel deployment. 23 days later, Mariner 4 caught the window, heading toward the red planet, with humanity's endless speculations about Martian life. In the late 19th and early 20th centuries, American astronomer Percival Lowell claimed he'd observed Martian canals, long, thin lines, publishing 3 books vividly describing canal-building Martians. Mars's true face was revealed on July 14, 1965. That day, Mariner 4 flew over Mars. The digital signals sent back required computer processing to form images. JPL couldn't wait. They decided to draw it themselves. Engineers hung data printouts on walls, each number representing a pixel's brightness. They bought brown, red, and yellow crayons, assigned colors to numbers, and started coloring. This crayon drawing became history's first Mars photo, shown worldwide via media days before computer-processed monochrome images. No canals existed, just cratered landscapes like the moon's. A New York Times editorial declared Mars likely a dead planet, but Mariner 4's findings went further. Scientists discovered Mars's atmosphere was just 1% of Earth's density, with polar ice caps like our poles. Its solid core couldn't generate a magnetic field or dense atmosphere, leaving it vulnerable to solar winds. In July 1969, Mariner 6 captured Mars' chaotic terrain upon arrival. It showed crater-filled deserts, collapsed ridges, and mysterious concentric circles. This mission shattered all fantasies of complex life on Mars. Temperatures plunged below freezing, the air thin with minimal oxygen. Not even plants survived. All right, that concludes Jupiter Planet's first phase of solar system planetary exploration. In the 1960s, JPL launched the Mariner spacecraft series, unveiling the mysteries of Venus and Mars. Next in Phase 2 came Mercury and the outer planets. By the late 1970s, solar system planets would align uniquely, with outer planets, Jupiter, Saturn, Uranus, Neptune, clustering close. The journey to Neptune would shorten from 30 to 13 years, a once every 166 years opportunity.
So in the late 60s, JPL ambitiously proposed Voyager, a plan to send two probes to these outer planets.
But America's space exploration climate had cooled significantly by then. Richard Nixon took office in 1969. Since Democrat Kennedy championed the moon program, Nixon saw NASA as Kennedy's political legacy, just a partisan pawn. Meanwhile, public enthusiasm for space exploration was waning. Even during Apollo 11's moon landing in the 1960s, only 39% of Americans believed becoming first mattered, regardless of cost. As the moon landing's glory faded, the Vietnam War saddled America with debt. Public support for the space race grew increasingly low. In 1970, NASA's budget was slashed by 17%. The Nixon administration deemed reusable space shuttles more practical than expensive, one-way rockets. This marked U.S. space focus shifting from exploration to practical applications. Voyager was shelved, but Mariner's inter-planet exploration continued. Mariner 10, launched in 1973, pioneered gravity assist, using planetary gravity like a giant slingshot through space. Gravity assist, spacecraft gained speed by skimming planets' gravity, drastically cutting fuel and costs. In early February 1974, Mariner 10 flew by Venus, arcing around it before reaching Mercury a month later. That planet's surface lay dead, with no true atmosphere, but featured an iron-rich, dense core and magnetic field. Scientists previously thought Mercury was too small to generate a magnetic field. Mariner 10's success proved gravity assist's viability to JPL. This technique expanded to other planetary explorations, including the renowned Voyager program. As mentioned earlier, late 1970s offered a once every 166 years planetary alignment that drastically shortened Neptune's distance. Voyager's goal was sending twin spacecraft to explore 4 planets from Jupiter to Neptune. But budget cuts led Congress to barely approve only Jupiter and Saturn missions.
JPL decided to stealthily achieve Uranus-Neptune goals, like their first satellite launch.
To reduce risk, they charted a shortcut for Voyager 1.
Its trajectory hugged Jupiter and Saturn closely, while Voyager 2 took a winding path.
In August and September 1977, both Voyager launched, beginning an epic interstellar journey. Each carried instruments, cameras, and a gold-plated copper record with waves, birdsong, 55 language greetings, and 90 minutes of music. From March 5th to April 13th, 1979, Voyager 1 traversed Jupiter's system, capturing nearly 19,000 photos, revealing its impressionistic atmospheric hues, pale blue and ivory bands streaked with dark crimson.
Io featured colossal volcanoes spewing sulfur-rich plumes.
This Jupiter encounter yielded discoveries equivalent to a decade's work. The next year, Voyager 2 flew over Saturn's rings, sunlight illuminating countless ice fragments, dust and rocks within. Some rings twisted like golden necklaces, others bore strange spokes resembling wheel spokes. JPL's imaging team abandoned counting them all. They told media wanting photos, "You count them yourselves." In November 1980 and August 1981, both Voyagers departed Saturn.
The good news! NASA now supported continuing their journeys. JPL's covert strategy succeeded again!
Voyager 1 headed directly from Saturn toward the edge of the solar system. In 1986, Voyager 2 encountered Uranus, appearing like a solemn crescent moon. Beneath its clouds lay a boiling ocean. Its moon, Miranda, featured a massive chasm 10 times deeper than Earth's Grand Canyon. 3 years later, In August 1989, Voyager 2 sent its final photos from Neptune to Earth. The photos showed Neptune as serene and clear, but beneath its calm appearance raged howling winds,
Reaching nearly 2,000 kilometers per hour.
the strongest winds anywhere in the solar system. After Voyager, JPL continued space exploration, like Galileo reaching Jupiter in 1995, detecting its hot, dry climate with 700 plus kph winds. Galileo also discovered saltwater oceans on Europa, Ganymede, and Callisto. In 2004, Spirit and Opportunity rovers bounced onto Mars, capturing stunning panoramas and far exceeding their 1-year expected lifespan. Spirit roamed Mars for 5 years before getting stuck in soft soil and losing a wheel. Opportunity tirelessly traversed for 10 more years. The Spirit and Opportunity projects were led by female engineer Sylvia Lundy. Sylvia joined JPL as a computer in 1968. By 1970, with Congress passing the Equal Rights Amendment, women's liberation reached JPL offices. For the first time, girls in computing became engineers with titles matching their qualifications. For new female hires, JPL required engineering degrees. But then, under 1% of U.S. engineering graduates were women. Caltech's engineering program only admitted women starting 1970. Helen hired smart girls as programmers and encouraged them to earn engineering degrees. From 1984 to 1994, JPL's female engineer ratio rose from 9% to 15%. By 2016, this book's publication, JPL employed more women than any NASA center, with women playing increasingly vital roles. This trend is exactly the opposite of other places in America. In 1984, 37% of computer science graduates were women, but now that percentage has dropped to 18%. In 1994, Helen retired. Over 40 years ago, when Helen first joined JPL, neither Mackie nor anyone else foresaw that these women could take on such significant responsibilities and achieve such high accomplishments. Even after leaving, the legacy they left behind continues to persistently explore the unknown. On February 14th, 1990, Voyager 1 turned back and took its last few photos. The most famous one is called The Pale Blue Dot, looking back at the solar system from 6.4 billion kilometers away, with Earth's size less than a pixel. And this tiny blue dot, surrounded by a universe so vast and magnificent. Then Voyager 1 left the solar system and entered interstellar space. It is the farthest traveled human-made object. But the heroes who built it were not all men. Around 2025, Voyager's plutonium-238 batteries will be depleted, but the silent traveler will continue on. For those fortunate to join the JPL mission team, Voyager is the pinnacle of their careers, their finest and most important professional achievement. The girls from the computing department often sat together in the auditorium, watching the continuous stream of photos from Voyager. The alien landscapes made them realize how special our Earth is. In Voyager 1's memory lies a treasure, a program less than 40 kilobytes. This code occupies less than 1/10,000th of an iPhone's memory. But they were written line by line by a group of outstanding Earth women using paper and pencils. These programs are not only a microcosm of their outstanding work, but also represent the peak years of their careers. Code soaring through cosmic dust is a gift these women left for the stars. That concludes the main content of this book. After hearing the stories behind the Apollo program, Mariner, and Voyager, do you have any thoughts you'd like to share with us? Welcome to leave us a comment in the comments section. This concludes our interpretation of the main content of The Girls Who Launched Rockets. Listening notes are below the audio. See you next time.